A skier is being pulled by a tow rope up a hill at constant speed. This is important, and we'll see why later. Draw a picture of the skier. Here's our skier. His name is Steve. So now we're going to draw a free body diagram of all the forces acting on our skier. So first, we're going to be focusing on our force of gravity and normal force. Since we know that gravity goes down, it goes in the negative direction, the y-axis. Since we know that normal it's pushing up against the skier, it's going in the positive direction. We should also point out that since it's constant speed, that means acceleration is 0. And since there's no acceleration perpendicular to the surface, the net force in the perpendicular direction has to be 0. This means that gravity must be canceled out by the normal force. Therefore, Fg equals Fn, as we can see here.
The next two forces we will be focusing on are the force of tension and the force of friction. Looking at our picture, we can see that the force of tension is moving in this direction, and that the force of friction would be moving in this direction. We know that the force of tension is the force exerted by the rope, and that friction is given by the equation F sub k is equal to mu sub k times the normal force. Because the skier is being pulled up the hill, we know that the force of tension will be greater than the force of friction.
Alright, so the net force is equal to ma, which is mass times acceleration. Since he's moving at a constant speed, the acceleration is equal to 0. Therefore, the net force is also equal to 0. Now, force due to normal minus force due to gravity is equal to ma. And again, since acceleration is 0, force due to normal minus force due to gravity is equal to 0. Therefore, force due to normal is equal to force due to gravity. Since these two forces are equal, for magnitude of normal is also equal to magnitude of gravity. Next, force due to tension is equal to force of tension is greater actually than force of friction. Therefore, magnitude of tension is greater than magnitude of friction.